For the second part of the 4.2 notes, we're going to start looking at being given an angle and then evaluating either sine, cosine, tangent, or the secant, cosecant, and cotangent functions for that. So instead of having the triangle with the given sides, you're just going to have the angle for these. You should already have these rules copied down in your notes, but we're still going to be referring to them frequently, so make sure you have them handy. The most important thing out of this is the sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then don't forget that the reciprocal functions, you just take those same side values and you flip them upside down. The special right triangle rules you should have seen before. What we're doing specifically with them today, though, is we're making the hypotenuse equal to the length of 1. So that's going to be the standard we use for a lot of our trig work. If the hypotenuse is 1, we used to say that the sides of the 45, 45, 90 were x. And then if you take that value and multiply it by square root of 2, then that would give you the hypotenuse. And that does still apply in this case, because if you have square root of 2 over 2, and you multiply that by square root of 2, then on top, square root of 2 times square root of 2 is 2. You divide it by 2, that just equals 1. So this is the same set of rules. The same thing is happening with the 30, 60, 90. So the short leg, we used to call that x. And if you multiply that by 2, then you would go from this side, doubling 1/2 is equal to 1. And if you take the short leg and multiply it by square root of 3, then square root of 3 times 1 over 2 is equal to square root of 3 over 2. So these are the same rules that you've used before for special right triangles, like I said. The important difference here is just that we're making the hypotenuse always equal to the length of 1. The first examples you're going to be working with will ask you to evaluate without a calculator, and then the rest of the examples we'll do with a calculator. So the first thing we want to set up on these is we're going to draw the appropriate triangle from one of the ones that we just looked at on the last slide. So you might need to remember to how to convert the angle measurements from radians to degrees. In this case, if you take pi over 3 and you multiply this by 180 degrees over 1 pi radian, then the pi radian units will cancel, and 180 divided by 3 will equal 60. So what we're going to do is draw a triangle that has a 60-degree angle in it. So looking back at the rules I just gave you guys for the special right triangles, we said across from the 60-degree angle is going to be square root of 3 over 2, and then next to the 60-degree angle is going to be 1/2, and the hypotenuse is always 1. So now we need to look at which trig function they've asked us to evaluate. In this case, they're asking us to find cosine. So looking back at our rules for SOHCAHTOA, that means I need to take the adjacent side and divide it by the hypotenuse. So for this example, my angle that I'm doing everything in reference to is this one, the 60-degree angle, because they're asking us to find cosine of 60 degrees. So the adjacent side is the 1/2, and the hypotenuse is 1. So cosine of pi over 3 is going to equal 1/2 divided by 1, which is just 1/2. For our next example, since I'm, I'll convert the angle into degrees for you guys first. So we have pi over 6, and we're multiplying that by 180 degrees over 1 pi radian. So the pi's cancel out again. This time I have 180 divided by 6, which is equal to 30 degrees. So I can actually reuse the exact same triangle we just drew a second ago. I can still use this one, because I still have my 30, 60, 90 triangle. However, I'm going to be basing my measurements instead of from the 60-degree angle like we did in the last one. Now we're going to be basing everything on this angle over here in terms of the opposite, adjacent, and hypotenuse sides. So the rule for tangent is the opposite side divided by the adjacent side. So from this angle, the 30-degree angle, opposite is 1/2, and we're dividing by the adjacent side, which is square root of 3 over 2, But remember that you can multiply by the reciprocal instead of having a fraction divided by a fraction. So instead of dividing by square root of 3 over 2, I'm going to multiply by 2 over square root of 3. And then the 2's in this case would cancel out so that you have 1 over square root of 3. But you need to rationalize denominators like this. You should not have a radical in the bottom of your fraction. So if you multiply top and bottom by square root of 3 over square root of 3, you're going to get square root of 3 divided by 3. Remember, anytime you have something like square root of x times square root of x, if it's the same number inside, the square root just disappears and you're left with the number that was inside originally. So the answer to tangent of pi over 6 is this square root of 3 over 3. For the last value, this one is using a different angle, so we'll convert it, and you'll see that we're going to need a new triangle for this one. So if I have pi over 4, and I multiply that by 180 over pi, the pi's still cancel, and you're going to be left with 45 degrees. Well, the triangle I've been using for reference does not have 45 degree measurements in it anywhere. So now we need to use our other triangle, the 45, 45, 90. And since those two angles are equal, I'm just going to make the marks to indicate that they're the same. And since this is 90 degrees, that means it has to be a 45, 45, 90. That's the only way that can happen. We said that the hypotenuse is always going to be 1 for the triangles that we're using here. And then looking back at the rule, if the hypotenuse is 1, that means the sides must both be square root of 2 over 2. So now we need to remember that the rule for sine is opposite over hypotenuse. Now, I actually have two different 45 degree angles in here, so it doesn't matter which one I use for reference. So if you pick this one, let's say that this is the angle we're doing everything in terms of, then for sine, opposite divided by hypotenuse, anything divided by 1 is just whatever the number was. So my answer is going to be the square root of 2 over 2. And you would get that same answer if you had picked the other angle, because from this angle, the opposite side is square root of 2 over 2, and the hypotenuse is 1. So either way, you end up doing square root of 2 over 2 divided by 1. So now we're going to start looking at how to evaluate these using your calculator instead. The first important thing I need to stress for you guys is to check whether the angle they're giving you is in terms of radians or degrees, and then make sure your calculator is in the same mode. So you have to be very careful. Like on the ones we were doing before, these were all in radians. So if you try to enter them with your calculator, you need to make sure you're in radian mode before you try to enter something like pi over 6. Otherwise, it's going to give you the wrong answer. Now, we did change the angles to degrees, so I could have put my calculator in degree mode and said tangent of 30 degrees, and that would have been okay. So that's my first important reminder to you guys. Look at the angle that they have given you. Make sure that it is in the same mode that your calculator is in. For the reciprocal functions, cosecant, secant, and cotangent, most calculators do not have keys for entering those. So what you have to do instead is remember what the reciprocal relationships are. If they say cosecant of 30 degrees, then you would enter 1 over sine of 30 degrees. Since they are reciprocals of each other, that will give you the same answer. So know the reciprocal pairs very well if your calculator does not have the ability to enter those original three functions directly. And then the last thing I want to point out is if they ask you for an exact answer, that means they do not want a decimal. That means they want the radical form. If they do ask for a decimal, then they should usually specify how many decimal places to round to. If not, a good standard is usually 3 decimal places, in my opinion. So here's the first example. Unfortunately, there won't be much work I can show you on these. I'm just going to encourage you to have your own calculator handy and then check with yours to see that you're getting the same numbers that I am. So on this first question, I can see that this is in degree mode. So first, make sure your calculator is set to degrees. And then I'm going to enter cosine 60 and hit enter. The answer I get from this is equal to 1/2. If your calculator does not give you fractions, it probably gave you 0.5 and left it there. And that's fine. This one didn't really specify which mode they want us to enter them in. I believe on your assignment you're going to be doing decimals for these. For the next one, I have cosecant. So what you have to remember for this one is that that's going to be the reciprocal of sine. So I'm going to think of it this way. And then notice again that our angle is in terms of degrees. I know it's in degrees because it has the degree symbol. If you don't see the degree, even if it seems like a number that's supposed to be in degrees, even if you see a 30 or a 40 and there's no pi or anything in there, if there's no degree symbol, then that is actually a radian measurement. It doesn't have to have a pi in it. So we'll see some tricky ones like that later. So degree symbol, make sure you're in degree mode. That's the rule of thumb. So for this one, you're going to enter 1 divided by sine of 45, making sure that you're still in degree mode. And for my calculator, I got square root of 2, but if you're entering this as a decimal, that's going to be 1.414. I'll just go ahead and specify in the other one just in case. The answer to that would have been 0.5. Now this last one, the angle measurement has changed. There's no degree symbol on here. So for my calculator, I have to hit mode, and then there's usually an option for DEG, RAD, or GRAD. So the DEG and RAD, the degree and radian, that's what you need to switch between for questions like this. And then you're frequently going to be switching back and forth within the same assignment. So right now, I'm setting my calculator to radian mode. And also, since this is cotangent, not tangent, I need to remember to do 1 divided by tangent of pi over 3. So type that into your calculator, 1 divided by tangent, and you're literally going to be using the pi key. Hopefully yours has one on there. So pi divided by 3 and close the parentheses so it knows that you're ending the angle there. The angle is pi divided by 3. The answer I'm getting for this one is 0.577. And that number is the same as square root of 3 over 3, but just in case your calculator can't enter the fraction form, I'm giving you the answer in this notation. So closing comments, again, please always check which mode your calculator is in. It's gonna happen to everybody at some point that they forget or they evaluate an answer in the wrong mode. So just try to put reminders everywhere that you can to remind yourself to check that. Also, don't forget when you have 2 of the sides of a right triangle, you can still use Pythagorean theorem to find the 3rd side. So then when you're trying to evaluate some of the opposite, adjacent, and hypotenuse sides, you should still be in good shape. That's all for the notes today. Thank you.